Hello, welcome. I'm Andrea Angela, and in this video, we are going to look at paper 2 of computing, AS computing. It's the paper from October-November 2016, the paper 21. Awesome. So let's have a look and try to do this. Okay, so the first question is, we have basically two different classes, economy and standard. We know that we have a baggage allowance of 16 kilos and 20 kilos, and we have a charge rate per additional kilos. And there is we need to write a program that calculates the baggage charge for a passenger's airline flight. We've been given a set of statements that obviously are out of order in order to actually do this calculation. So pretty much is the idea is that based on the ticket type, you have a particular allowance, and then for any extra additional kilos, you need to pay some money. So this program is actually need to do that. The first question that we have in the paper is to actually fill this flowchart with the actual number of the instructions that the correct instruction. So we have the first one already given to us, the number 5. So you can see number 5 is input ticket type. So the first things the program does is getting the ticket type. Okay. How could you approach this? So you can see that there are different instructions here. Charge is set to 0, then we get the baggage weight, then we calculate the charge, multiply the excess weight by the charge rate. It makes sense, but the charge rate also need to be set based on the ticket type. Then we have a statement that check if the excess weight is greater than 0. We set the excess weight to be equals to the baggage weight minus the baggage allowance, but we haven't calculated the baggage allowance yet. So the allowance is 16 or 20, so this also need to be based on the ticket type. The same for the charge rate, and then we also print the charge and so on. So you can get an idea what the algorithm is about. The way to fill this one could be you could basically have different approaches. So one that I would consider is that you can see from this flowchart that there are two if statements in there. So which one of the two will probably go first? Let's have a look. We have one that's checked that if the ticket type is economy, and one that checked that the excess weight is greater than 0. But obviously we are not able to calculate excess weight until we know what the ticket type is. So is ticket type equals E is going to be first. So so that's basically help us to put here 12. That is actually checking the ticket type is economy. And so this means that the other if statement need to be here, that is 4. Okay, so here we check if the ticket type is economy, right? So this means that if here could be no and here could be yes. So we need to do two different things based on if it's yes or no. And then obviously we have checking that if the excess weight is greater or not. So if it's greater than the allowed weight, we need to pay some charge. Otherwise, it's gonna be there will be no charges. Okay, so let's see. In order to do this if, what do we need here? We need the ticket type. Let's see. We have ticket type. The first instruction, we already have input ticket type, so we already have ticket type. But what else we might need to do? We also probably need the other inputs, right? So ticket type, we got it. The other one is baggage weight. So number 2 is going to be here. So before doing any actual, if we actually do the two input statements, we get the ticket type and we get the baggage weight. Then we check if the ticket type is economy. If it's economy, is what we do. We do 2 instructions here, and here we do 2 instructions. And here is relatively easy to understand what's going on, because we have a baggage allowance and charge rate that are different between the ticket types. So this means that we need to set them based on the ticket type. So a baggage allowance set to 16, number 7 is economy, and 3.5 as charge rate is economy. So 7 and 8 need to be done if the ticket type is economy. So if it's economy, it's a yes. We need to do 7 and 8 here. Oops, 8. While if it's not economy, means that it's a standard ticket. So we need to set to 20 the baggage allowance and to 5.75 the charge rate. So it's going to be 11 and 10. Doesn't really matter the order, right? We're just initializing a variable, so both will be fine. Awesome. As soon as we've got that, in order to do the next if statement, we need to have, so if you see number 4, is excess weight greater than 0? We need to get the calculate the excess weight. But so we can do that with number 6. You can see that we set the excess weight variable. So number 6 is the processing operation we need to do in order to be able to do the if. So as soon as we got the data set, we calculate the excess weight, and based on the excess weight, we decide what to do. So if there is no excess weight, what does it mean? It means that we don't need to charge anything. So charge set to 0 looks like is the right things to do here. So that's set 1. Alternative, we need to calculate the charge. And let's say we have an instruction here to calculate the charge. Let's see, charge equals excess weight by charge rate. Okay, and that's basically what we need to do. And finally, we need to print the result, and that is output charge, that is number 9. And there we go. So we have the algorithms. So the algorithm is relatively simple. You get the ticket type and the baggage type. Then you iterate. Then you do an if statement. If the ticket type is economy, set some values for the baggage allowance and the price. Otherwise, set 2 different values. Then calculate the excess weight. Based on that, calculate the charge or not. Okay, and at the end, print the charge to the screen. So the flowchart is a way to represent a program in a more expressive way, and where it's more clear what are the possible paths that you can follow, to actually run the program. As you can see here, you can just do this path, or you can do just this path. There are 4 different paths that the program can actually, the flow of the program can actually takes. And actually, this is exactly what is being asked afterward. So the next question is, okay, right, we need to actually test this program. What kind of input do we want to give to the program in order to test all the possible paths? Actually, here is giving you 5 tests. Okay, it's true that there are 4 possible paths based on because there are 2 conditional statements. There are 2 to 2 paths. That means 4 paths. But this doesn't mean that you can't have more tests, because what if there's an error, for example? So a possible way is actually testing errors. If the input that you provide is incorrect, you might generate an error. So that's other possible input. Okay, so let's do the epic cases first. So the cases when the program actually works. So we have already a ticket type economy and baggage weight 15. So what's the explanation here? So what we are testing here is that we have an economy ticket and the weight is under the allowance, because 15 is less than, what was the allowance? 16 is the allowance for economy and 20 for, let me write it here, 16 is for economy and 20 is for standard, the allowance. So basically what we are testing here is an economy ticket and weight under the allowance. Okay, we are testing that actually we get 0 as the output. So we expect 0 charges in this case because we are below the allowance. The other possibility is that we still have economy, but we are above the allowance. That, let's say the allowance is 16, let's say 20. 20 is definitely above that. So the explanation is economy ticket and weight above the allowance. And what will be the result? So basically we get a charge of 3.5 for extra kilos. There are 4 possible kilos extra, so we need to be charged 14. And then the other 2 cases are standard prices below and above the allowance. So let's say 19 is definitely below, and let's say 23 is definitely above. So standard ticket and weight under the allowance, and obviously there will be no charges. And the other one is standard ticket and weight above the allowance. And what will be the charge? So the charge is, let's have a look, 575. So you need to do 575 by 3, that is the extra weight. That is basically 1725. Okay, and finally, let's simulate some error. So let's say we actually select the economy, but we provide, like, say, a negative baggage weight. So in that case, obviously, we are testing an invalid weight, right? So in this case, we would expect maybe a sort of error message, for example, or something like that. Okay. That's actually basically doing white box testing. We are actually testing the code based on how it's written. So next, we have been asked to actually change the program so that you do some sort of validation when you actually ask for the ticket type. So you do not allow the program to carry on if the ticket type is not correct. So you need to write some pseudocode to do that. All right. So first of all, we need to obviously input the ticket. Type. And then we need to do a loop. So let's do a while loop. So we while not ticket type equals E, or ticket type equals S. So until it's not E or S, what we do? We just do input ticket type. So we keep doing input ticket type until the ticket type is that we get is E or S. So it stays inside the loop until it's not E or not S. Okay, so that's actually the pseudocode that we need to write in order to implement this. So next we have a sensing device that sends bits values to a computer using data channels. We have two channels, channel 1 and channel 2. The first one transmits a sequence of binary values, and the second one transmits a regular intervals to indicate whether the sensor is switched on or off. So 0 is off and 1 is on. We have a program test the bits received from the sensing device that reads the signal from channel 2 after every 6 values from channel 1. And we have a built-in function read channel number that actually reads a value from the specified channel. So we have some pseudocode, and we've been asked to actually do a tracing of the program, right? So let's have a quick look about the program just to see if you can get an idea of actually what it does. We set bit count at 0, and we read from channel 2. So we start reading from channel 2. Then until the status is 1, so this basically means that until it's switched on, so you actually do 6 reading counts from channel 1. But it actually goes to this bit. If the bit is set to 1, we actually count the bits, so we increase the bit count. However, if we hit the bit count to 5, we print out an error, and then we reset the counter, right? And then after 6 reads of the channel 1, we actually read another bit of the channel 2. And if it's 0, we just stop. Okay, all right, okay, cool. Let's try to trace it and see if we can get an idea of the execution. So we already have something. Oh, let me take the writing here. So we start from bit count at 0. Then we read the status 2 is 1 because we read a bit from channel 2. So the reading count goes to 1 because we received a 1, and that's a 1, and then this bit is 1, and then we count to 1. Right. So basically, what we did is we set bit count to 0. We read the first bit from channel 2. It's 1. So we entered the loop, and we enter the for loop. We read from the channel 1 a bit set to 1. We check that that's set to 1, and then we increase bit count, so that becomes 1. Bit count is not 5, so we carry on to the loop, and then reading count becomes 2, right? And that's actually need to go in a separate line. Okay, so that's basically is carry on with this logic. So we have reading count. What's the next bit from channel 1? It's 0. It's here. This bit here is 0, and so bit counts doesn't change. We stay 1. Then we carry on with the loop. That becomes 3. What's the bit now? Is 1. So we carry on counting, and this becomes 2. Then we carry on with the loop. This becomes 4. What's the bit we read from the channel in position 4? 1, 2, 3, 4 is 1, so that's the count will increase. Then we read we actually move to 5. The bit that we read is another 1, and this goes to 4. Then the reading count becomes 6, so we are looking at the last bit from channel 1. The bit is 0, and what we actually get is 5. Is that correct or not? Let's have a look. So we are reading count 0, and this bit is 0. So reading count is 6. This bit is 0, so that's not gonna change. But bit count becomes 5. So this is actually gonna change. Sorry, I made this become 4, and 6, 0. So reading count is 6, and this bit is 0. Reading count is 6, this bit is 0. So that's not increased. That should become 5. Yeah, that should become 5. Okay. So the most important things here, and is what's actually easy to make mistake, is what to put in the same line. It's very easy to get confused because you need to make sure to check when actually the value change. So let's properly have a look at that. So what happened is that this reached 5, so the counter will be reset and there will be a print of the error. So where should we put that here? Should we put it here in the output, or should we put it in the next line? Let's have a look. So this should becomes, let's put in the separate lines, because we want to actually say this will be reset to 1. So we actually, this get to 5, then we print the error investigate, then reading count gets back to 1. Oh, no, before that we read the status 2, so this gets back to reading 1 becomes 1, reading count becomes 1, and this bit becomes 1. Okay. Yeah, that should be correct. So then we need to do another loop. So, and this will be reset to 0, because as you can see, this is set to 0 as well. Okay, it's not immediately clear what should be, but that should be fine. Then we set to 0, and the next iteration we carry on counting. So we read the second bit, that is 1, that is this. So this become 1, and this become 1. Then we carry on, we just read the number 3, then we read the bit 0, and then we carry on counting, that become 1. Then we get 4, that this becomes 0, and this becomes 1. So then we carry on. 5, what's the bit in position 5? Here is 1. The bit count becomes 2. So it's increased because it's 1. Then we go to 6. Then we read another 1, and then we'll be counted to 3. But then we read the second channel, and it is 0. And then because it's 0, we end the loop. And that's pretty much that. Okay. Okay, cool. So we want to have a quick review. So the idea is that you need to actually, obviously it's a bit difficult with the PDF here because we need to go back and forward. It's a lot easier if you are doing that on paper. You need to actually, so my advice is actually to keep pen at the position of the line of code that is executed, and actually moving the pen based on how the program executes. And while you are doing that, actually fill the table. That's actually the best way of doing that. Okay. And the idea, you actually move to the next line on the tracing as soon as there is a change in one of the value. So actually, I could have put a 5 there. That would have been fine. And then investigate that, and then this line separately. But I don't think they should really matter for the valuation of the tracing. Okay, so the next question is, you've been asked what is an assignment, what is a selection, and what is an iteration. So here again, you need to go back to the program and have a look at what are assignments, what are so assignment are like 1 and 2, 6 is an assignment, 9 is an assignment, basically setting a variable, 14 is an assignment, and 18 is an assignment. Then you need to check what are the selections, and basically it's the if statement, is 7 and 11, and then iteration, while loop is an iteration, so location 3, and location 5, the for loop is an iteration. So I think you can just add 1 here, but basically you can add any of this is valid, 9, 14, and 18, and this one is, as I said, 7 and 11, and this is 3 and 5. Right. Okay. So next we have an ASCII code table, and we are asked basically to write the value of the variable after running this particular statement. And bear in mind that at the end of the PDF there is basically an appendix. So it's actually saying that there are some function here at the end. Let's have a look. Yeah, there are some one char, character count, substring, tunum, ask, character, and random and integer. So you actually need to use that in order to solve this, to be able to answer these questions. So character count is actually counting the number of characters inside the string. So that's relatively simple. So how many letters there are in tsunami? That's actually 7. So let's put it there, 7. Then ask actually get the ASCII code of the letter G, that is 71. So this is basically 71, and the ASCII character of the space is actually 32. So the sum of those is 103. Then the next statement is character count of hello, that is 5, plus 70, you get 75, and then you need to get the character value of the ASCII code 75, and the ASCII code 75 is K, right? And then you can put here K as a character. Excellent. Then you have welcome home 47. It actually is a substring. Bear in mind that the pseudocode indexes start from 1, while maybe if you write in Python, you need to remember that it's actually the index starts in 0, and most of the programming language available are actually using 0. So the pseudocode is a bit confusing because it's using 1. So pay attention. So 4 means that is 1, 2, 3, 4. C is the actual first character to consider, and then you need to take up to 7 to position 7. So C in position 4 and E is in position 7. So you need to take all the characters in between. So the result is a string come. Right? So the substring is actually taking a substring from a string, and you give given the start index and the end index of the substring. Okay. So what we are asked next is to we have another program. What I want to do, we want to calculate the customer ID, and we have from the customer surname. And the procedure is that you get a surname, you isolate each character in the surname and find the corresponding ASCII code. You calculate the total of this ASCII code, and then you return the customer ID, that is the total, right? So you have a procedure here that we need to fill that actually does that. So okay, we write the key in surname, then we input the surname, and then the length is going to be the length of the surname, because that is used in a for loop in order to iterate through each character. So the length, we already have a function in the appendix that we know is called character count. They actually count the number of characters in the surname. Then we iterate. Next char is a single character from the surname. So we have another function in the appendix that's called one char that takes a string and I, that is actually the location that you want to extract. And now we have the character. We get the ASCII code using the ask function, and then we need to add this next code number to customer ID. Right, so the customer ID is actually the sum of all these ASCII codes, and that's it. And then we've been asked to actually write some code, program code that actually does that. So let's use Python, and then I switch back to my editor. That is PyCharm that I'm using. And so what's the program looks like if you write it in Python? So that's what I created. Make sure you actually put the variables that you use in a comment that is required as part of the examination. So we're using a variable surname that is a string, surname length, the next code number, and customer ID that is an integer, and include NDI as well. And the next is a character. So we ask the enter your surname using the input. Len is the function that we use to calculate the length of the surname, and then we set customer ID to 0. Then we do a loop using the loop statement in Python. So we do a for loop from 0 to surname length. Then we use the this syntax here to actually get a character value from the character value in position I, and then we get that. And then ord is basically the function that returns the ASCII value of the next character. Then we got the next code number, then we add it. So it's basically translating the pseudocode we've seen before using Python. And then at the end, I just printed. This is not required for the. Is that required? Let's see. After the end, it's doing print. Yeah, it's doing print at the end, so that's definitely required. So, and then if I run that, as you can see, I can do right click, run, and you can put your name, and then you get customer ID is 50007, right? So if you want to test it a bit better, you can just try a single letter, A, capital A, and you know that the ASCII code of A is 65. So you can just do and play a bit with it. So that's actually the program that I would write in order to calculate the customer ID given the surname. Excellent. So let's get back to the paper and see what's next. Okay, other program code you need to write. Let's still use Python. So we want to change the code that we wrote before in order to make that as a function instead of just a procedure, instead of just a program code. So if you want to do that, what do you need to change? The function header for this new function you need to change. So the function will be def calculate customer ID, and they will be taking the parameter as the surname as a parameter. Instead of actually doing the input, we will actually take it from the outside. And the statement, the additional statement required within the function body to complete the change from a procedure to a function, right? Here we actually set the customer ID, and then we print it. Well, if this was a function, we would just return the customer ID, right? So that means that we need to actually do a return at the end of the function to actually return the value to the caller. Okay, so each function needs to have a return statement, or at least one return statement to return the value. And then you've been asked to actually, how can I call this function using and assign the result to this ID, and you actually search for a surname Wilkes. Okay, so that's pretty much a statement, assignment statement that you need to call the function calculate customer ID, and you need to pass the surname Wilkes that you actually want to use to generate a customer ID. That's how you call it. Then, okay, so now we are being asked what's the difference between built-in function and a use-defined function. Okay, so built-in function are actually a set of functions that you can modify, that you actually get by default when you actually install the system, when you install Python, and you can actually use them and leverage. You have a lot of functionalities already in place and ready for you. So definitely one of the functions that, so one of the differences that actually built-in functions are already available in the system. All right, but the problem is that they can be changed. So you need to do use-defined function in order to actually create custom behaviors, right? So built-in functions can be modified. So if you want to modify them, you need to create another copy of them and actually make some changes. then state two things that built-in and user-defined function have in common. So the idea of function is that the function has been created in order to simplify writing code, so that you can actually reuse code that in different programs. So basically, you can have a different application that all needs, a function that calls the counted number of characters as string. So you can actually reuse that code instead of reinventing the wheel every time and rewriting the same code over and over in different application. You can write a function and then reuse that in different places. So they both represent reusable code for sure. And the other things is that, of course, they are function. They all have a signature. So it's definitely something they have in common. They have a signature. So a name, a return value, and a list of arguments. That's basically what you need to do. Okay. So next, we have a company employs Ahmed as a programmer, and is using a text editor and a compiler. And then you need to describe how you could have developed programs using these two software tools. And you need to use object code and source code as part of the description. Okay, so obviously here is relatively simple. It's basically using the text editor to write the source code, and then use the compiler to translate the source code into object code, because that's the goal of the compiler. So basically, Ahmed writes and edits the source code using the text editor, and the compiler translates the source code and produce object code. That's a possible way to describe it. Then you need to say, okay, right, but if you, instead of using the text editor, you use an integrated development environment that provides a lot more support. So what is one of the features that the IDE provides to help to identify syntax errors? The one I like the most, for example, is the highlight errors as you type, using highlighting the words that at the location of the code where there is an error. Then you need to state one feature that the IDE provides to carry out white box testing. Okay, so as we've seen before, white box testing is actually kind of like having a look at all the code and understand the path. So one way that's quite useful is actually to the watch window to trace the value of variables, because you can see the value of the variables over time as you move forward in the program, and that's extremely useful when you want to do some testing, right? The next question. So we have a structured diagram that shows that we have a product addressing, add a product, and search for product, and then we pass the product code. We can do a search by product code, by description, or by price. We have been given a file that contains product code, a product description, and product retail price in basically 3 different lines. So this is a file where each is made of different groups of 3 lines. So each 3 lines actually contains information of a product. And you've been given some variables, products as a text file. P code is an array of 1,000 strings that are actually used to store product codes. An array of 1,000 strings that contains the descriptions, and an array of 1,000 strings that contains the retail price. And then you have an integer I. So, okay, you need to write a code in pseudocode that basically read the file and populate these 3 1D arrays with the information read from the file. So how can you do that? You need to, first of all, read the file, and we know the file is called products. So we do an open instruction reading products for read. Okay, file. Then we need to iterate through the file. So we need to actually do a full loop inside the file. So we need to carry on until we reach the end of file. So carry on until we found the end of the file. And then here, okay, read file products. Basically, we assign the what we read from file. So read file actually read a line from the product file, and then assign that to the variable p code I that start from 1. So we basically want to assign p code, p description, and oh, actually here there are more lines because obviously the third element of retail price is of type real, no strings. So because this is a number, so we want to convert that to numbers. So this first will get a string, but then we need to convert that to a real before actually setting. So we can't really do p retail price I straight away because that will fail because we're trying to assign a string to an integer. So let's use a temporary variable. Let's call it let's call it price, right? And then we need to set it retail price I, and then we convert that to real. And I think we have a function at the end in the appendix that is called toNum that actually allows to do that. Let's have a quick look. toNum returns the integer or real equivalent of the string. Perfect, that's exactly what we need. So let's use it. So we can actually set that, and now obviously we need to carry on moving I forward so that the next 3 lines we read, we are going to set the following location in the array. Okay, so we will fill the products array as much as possible until we reach the end of the file. Excellent. Then we say, okay, right, let's say we store, instead of using 3 lines, we store the product information on a single line. So we store the product code, the description, and the price in a single line. So state one benefit and one drawbacks of this design. So certainly one of the benefits that you reduce the number of reads that you need to do, right? Before with the code that we wrote here, we need to do 3 read files statement for each product. But if you use this structure, a single read file will actually get the whole product in memory. So a single line will contain all the information you need in order to actually relate to a particular product. So that's definitely one of the benefits. So reduce the number of file reads. File reads. One of the drawbacks, however, is that unfortunately, before it was easier because there was only 1 information per line, but now there are 3 information per line. So you need to do some extra code in order to extract the information you need from the line. So that's definitely a drawback. So it might take more time, or it might be hard to do, depends on how you format it. So basically, the program needs to parse the string, isolate each of the 3 items of data. Excellent. So now we've been given, we want to write the search by product code procedure. We have 4 variables: search code, that is a string, this index, that is an integer, this description is a string, and this retail price is a real. And you've been asked to create, to actually complete this structured chart that describe a possible high-level way of describing the program. That's relatively simple. So you have an input search schema, search criteria. So the search criteria that we want is the search code. So the input is the search code. The lookup by product code actually get the index information, right? And the search for product code, we return the 2 information from the file, and the 2 information are the description and the retail price. So the description is a bit too big. The font here. Let's decrease it a bit because otherwise it's too big. Let's move the description here. Oops, it's still too big. Slightly smaller. The description here, and here we have this retail price. Okay, so the search for product code, given the index, look into the into the arrays that we read, and that returns the description of the retail price. And then the output details actually requires all the information, requires the search code, requires the description, and requires the retail price in order to actually print the details. Okay, so the input of the function is the search code. The lookup code returns the index of that particular product, and then you look into the search for product code, look into the array and get the description, the retail price, and then all the three information are provided to the output details module that actually print it. And that's actually how the information flows. The next step is to write some code. Still, we're going to use Python again. And what we need to do, we want to actually implement some of this code. So the product code search takes return an integer. So it takes the product code, and if the product code is found, it returns the index position in the 1D array code that's being searched. Otherwise, it returns -1. Okay, so let's have a look how I would design that product code search. That's how I would write this code. So this one, the first line, you don't really need it for the exam. I just did that in order to be able to actually create a pre-populated product code list. So if you actually take this code, you can see that it's if you take some Python here, for example, and if I do that and I use like 10, basically I get a list of 0 to 9. So I simulate the product code to be just a number. Okay, so the function is like that, takes the search code, then iterate through the P code array from 0 to 1000, because we know it's 1000 long. If the search code match, then we return I, so the position of the array. Otherwise, if we actually carry on doing the for loop and nothing is found, we return -1. So that's the very easy way of doing that. So I really like to return from a function as soon as possible. So there is no problem to wait to have more than one returns in a function. So as soon as you can return, just do it, instead of actually creating temporary variables that remember the location of the position I in the array, and then at the end does an extra if to return stuff. So when you have the information that you need and you have everything you need to return from a function, I actually recommend you to do it. And actually, we only use I, that is the variable integer, in order to implement this. So back to the paper. We have the last question that is about, we have this pseudocode statement, and we need to print the final value of these 4 variables. Okay, so let's see what happened here. Let's read the code and trying to put the information of the value of the variables as we go along. So the first pi is 3.1. Then we declare the variables ABC, blah blah blah. These are all real and integers. We declare answer 1 that is a boolean. Okay, base is set to 2.4, 8 is set to 10, and then triangle is the base by 8 divided by 2. That gives 13. Okay, then radius is 1 and 2. The cone is calculated. You can do, using the calculator, you can do this math, and you will get 18.6, because obviously radius is 1, pi is 3.1, radius is 1, and height is 2. So you can just do the math, and you get that. ABC, then you do, so A plus B plus C is 23. 23 is greater than 28 is false, but there is a not, so this becomes true. Okay, total is 34, total -2 is actually 32. And then answer is A plus C by C, so A is 13, and C is 3. So 3 by 3 is 9, plus 13, you get 22. Okay, and that's basically what we need to put here. So the triangle is 13, cone is 18.6, answer 1 is true, total is 32, and answer 2 is 22. Fantastic. So that's actually is the end of the paper. If you have any questions, just feel free to ask me over Slack. And as usual, all the code will be available on the repository on GitHub, and I will share the link with you on the Slack channel. Thank you very much, and see you next time.